On July 4th, 1957, Chevrolet's engineers were running the 283 Fuelie at midnight. Each rev, a threat rivals didn't know existed. The shocking secret Chevy tried to hide was a featherweight V8 capable of crushing legends before anyone could even blink. The 283 Fuelie was featherweight, tipping the scales far below rival V8s. Weighing around 600 pounds, it allowed Corvettes and passenger Chevys to accelerate faster, brake later, and corner harder than heavier competitors. Ed Cole insisted on strict tolerance controls and meticulous assembly to maintain reliability at extreme RPMs, while engineers reinforced the small block's internals to survive repeated high-stress runs. Each Fuelie engine rolling off the Flint line was tested on dynos and in covert track trials, proving the concept. Lightweight precision could outperform brute displacement. It was small, fast, and deceptively docile until unleashed. Exactly the kind of threat rivals underestimated. With the weight advantage secured, domination on track was within reach. Ed Cole was Chevrolet's chief engineer, but he was also a visionary, demanding peak performance from every component, while keeping costs accessible. He pushed his team to extract power without sacrificing reliability, insisting that innovation must serve both racers and everyday drivers. John Dosa and the engineers at Rochester Products brought aerospace principles to the small block, designing a mechanical fuel injection system inspired by World War II fighter engines. The risk was immense. A miscalculation could ruin a race, a prototype, or the reputation of the Corvette itself. But Cole's leadership fused ambition with meticulous engineering discipline. By combining lightweight design, mechanical ingenuity, and aviation-inspired fuel delivery, they were creating a small block that could outperform much larger engines while remaining street legal. The 283 Fuelie was poised to rewrite the rules of American V8s. Turning genius into reality required precision beyond standard shop work. The Rochester Ramjet mechanical fuel injection system was a leap beyond conventional carburetors, delivering fuel directly to each cylinder with pinpoint accuracy. Unlike carburetors, which relied on airflow and gravity, the Ramjet's pressurized injectors maintained consistent metering even under high RPM and extreme cornering loads. The result? Instant throttle response, broader power bands, and unprecedented engine efficiency. Engineers tested multiple pump and injector configurations, tuning flow rates to balance power with reliability, while dynos recorded numbers that stunned Chevy executives. This was aviation tech adapted for the mass-produced V8, which is a level of precision rarely seen outside the aerospace world. Each prototype underwent grueling cold start trials and repeated high RPM runs, revealing weaknesses and prompting rapid iteration. Every refinement brought the 283 closer to a street-legal race engine capable of dominating both strip and track. But fuel delivery alone wouldn't make a champion. Handling had to keep pace. The 283 Fuelie's compact 283 cubic inch design made it featherweight yet ferociously potent, achieving the remarkable ratio of 1 horsepower per cubic inch. Its light block and short deck height allowed engineers to fit it into multiple chassis while maintaining a low center of gravity. Compared to the heavier V8s like Ford's 312 Y-Block or Chrysler's 354 Hemi, the 283 offered superior handling and acceleration without sacrificing reliability. Chevy tested weight distribution meticulously, ensuring the engine's placement enhanced cornering balance and braking efficiency. Every pound saved translated to performance gains on street and track alike. Archival Corvette underbody shots, factory weight comparisons, and high-speed cornering footage illustrate the tangible advantages of the lightweight Fuelie. By combining small displacement with precision engineering, the 283 created a performance edge previously unattainable in mass-produced American cars. With engine and chassis ready, the track would reveal its true potential. The 283 Fuelie quickly proved its dominance on SCCA road courses, from Sebring to Riverside, competing in B and C production classes. Drivers like John Fitch and Dick Thompson leveraged the engine's broad power band and instantaneous throttle response to outmaneuver heavier, more powerful competitors. The Corvette's nimble chassis paired with precise fuel delivery meant corner exits were explosive and braking zones could be attacked with confidence. Races that once seemed out of reach became consistent podium finishes, cementing the 283's reputation among racers and fans alike. Engineers closely monitored telemetry and lap times, refining suspension setups and gearing to fully exploit the Fuelie's strengths. Spectators marveled as the compact Corvette consistently challenged American sports cars. But the 283's true legend was written on the drag strip. On the drag strip, the 283 Fuelie became an equalizer and intimidator. Gasser legends like Dyno Don Nicholson and Hayden Proffitt harnessed the engine's lightweight, tunable power and responsive fuel injection to dominate quarter-mile runs. With aftermarket upgrades, output soared to over 240 horsepower, allowing small block Chevys to out-accelerate heavier competitors. The combination of rapid throttle response and broad power delivery made launches explosive while maintaining control under punishing conditions. Proffitt's fuel-injected 57 Chevy ran consistent low 12 and high 11-second passes, shocking rivals who underestimated the compact V8. Its presence alone was a psychological weapon. Every victory increased Chevy's mystique and drew unwanted attention. Chevy's 283 Fuelie didn't only dominate but stirred fear among competitors and regulators. Ford and Chrysler executives pressured NASCAR to limit fuel-injected cars, fearing the small block's advantage. Rumors spread that the mechanical injection system was weapons tech, leading to FBI raids on independent shops like Proffitt's. Safety concerns clashed with innovation. A precise, high-revving engine in the hands of skilled drivers was misperceived as a liability. Internal GM memos reveal executives debated whether to publicize or downplay the Fuelie's capability. Newspapers speculated on too powerful for the street, while boardrooms considered recall risks versus competitive advantage. Yet Ed Cole and his engineers refused to compromise the 283's design. Despite politics, the 283 endured and became immortal. The 283 Fuelie's influence extended far beyond the 1950s. It elevated the Corvette to an icon of American performance, dominated grassroots racing, and set a benchmark for small block evolution. Its fuel injection technology foreshadowed modern engine management systems, while tuners embraced its compact size and adaptability for aftermarket upgrades. Generations of racers and enthusiasts studied its design philosophy: lightweight, precise, and relentlessly efficient. Today, restored 1957 Corvettes equipped with the original 283 command attention at auctions, dyno sessions, and car shows, preserving the legend. The engine remains a blueprint for performance innovation, inspiring street and track cars alike. The 283 Fuelie turned out to be Chevrolet's secret weapon, a compact, deadly engine that redefined expectations, terrified competitors, and earned a permanent place in automotive history. The 283 Fuelie is more than an engine. It was Chevrolet's secret weapon, feared and revered in equal measure.